everyone, and welcome to today's webinar, Future-Proofing Factories, the Seamless Data Connectivity Blueprint. My name is Jen, and I will be facilitating today's session. We have a lot of valuable information to share today, but before we get started, I want to cover a few quick housekeeping details. At any time during today's session, you can submit questions via the Q&A panel feature of your screen. We'll save questions until the end, and we'll get to as many as we can. If we don't get to your question today, we'll be sure to follow up post-event. This session will be recorded and will be made available for replay after today's event. Now I'd like to welcome our speakers, Daniel and Kyle.
Hi, everyone. Thanks for joining us. I'm Dan Kirsch with RT Insights Research. I'm a principal analyst here. Been an analyst for about 15 years, focused a lot on cloud, on data, real-time data, and of course, driving analytics and business results from data. And I'm joined on this webinar from Kyle from PTC Kepware, who's generous enough to sponsor this webinar. Kyle, why don't you go ahead and introduce yourself?
Sure. Thanks, Dan, and thanks for having me. Hi, everyone. My name is Kyle Carew, and I head up the enablement team here at Kepware.
Great. So today we're going to be talking about factory automation and a few key steps to future-proofing your factory, and not just future-proofing, but also modernizing your factory. So some of the key points that we're going to be talking about today are a device-agnostic approach to connecting a factory, destination agnostic. So you're going to connect all of the elements of your factory. Where are you going to put that data? It might be on-prem, it might be on the cloud, it might be on-prem and the cloud. And then we're also going to talk about this concept of creating a single data hub, because it's great to connect your data. That's all important, and there's this drive to connect data, gather data. But at the end of the day, data is useless unless you're doing something with it. So our thought is really all of this connecting and transporting data is all about creating a data hub where you can create new use cases and get results from your data and change the way you do business. So why don't we start with device agnostic? So what's interesting about this is, as Kyle and I were talking, and I was talking to some CIOs at some industrial type companies, there's really no two factories that are the same, even if it's the same company. One's on the East Coast, one's on the West Coast. They're going to have different elements within the factory, and that could be different manufacturers of parts. It could be that you're at different elevations and there's different impacts on your on the factory and how different machinery works. And so one of the challenges, how do you connect these different elements, some of which were built way before digitalization. So I'm thinking of like a CNC machine or a purpose-built packaging machine that could be from the 60s, and it does what it was designed to do really well, but it was never meant to be instrumented. And so that's a real challenge. So Kyle, what are you seeing out in the field when you're working with clients?
Yeah, for sure. Yeah, so there's a lot to unpack there, but it's all good stuff. So I guess I'll start with something we like to say here is that every factory is the same. However, every factory is unique. And really what we're saying there is, all factories out there, all manufacturers, they want to increase their productivity. They want to increase their quality. They want to make sure they're monitoring everything. And, ultimately they're trying to increase their OEE and just, produce parts better. However, the challenge that we see is in order to do that, you need, I'll call it information superiority, meaning that you need to be able to collect data from every single resource that is out there on the floor. As you mentioned, there's usually a mix of both modern technologies as well as legacy. So you might have, I used to draw my Rockwell days, but you might have this really slick L8 processor that's running this whole half of the factory right next to a PLC5 that was produced before I was even born, sort of thing. And both are running the factory. So you need a way to collect all of that data to turn it into information so that you can go and look at the challenges and look at the issues that you might be having on the plant floor. So there's that one challenge of having modern and legacy equipment. The other challenge is there may be a mix of different vendors with their own protocols within that factory. So you might have a mix of, hey, I've got something specific like a Siemens or a Mitsubishi PLC. I might have a Rockwell PLC, and within those vendors, I might have different flavors of PLCs that maybe are talking different protocols. On top of that, maybe I also have just generic Modbus devices out there, or hey, I have databases. All of this data is important to have to turn into that information, but the challenge is, of course, how the heck am I going to go and get all of that stuff, right? So really what we recommend, and I'm going to try not to make this a huge Kepware commercial, but you're trying to find a solution where you're going to have one platform that's going to be able to ingest all of that data to complete your data set, so that when that turns into information, you have the entire picture and not just sort of these hate to use this buzzword, but data silos out there, right? In the past, really what we've seen is data silos, meaning, hey, each machine was sort of its own data silo. That has since kind of gone away. But now when we're looking at big data and trying to gather as much data as we can from the factory floor, this is now including some, I'll call it non-traditional factory equipment, meaning like, hey, we actually want to tap into the HVAC system. Hey, we've got these old CNC machines that we need stuff off of, or hey, we've got a manual process that we want to monitor, but in order to do that, we need to put these let's call it MQTT sensors on here, or some sort of sensor or other device that has a very specific protocol. That's important data to gather, but how do you go about doing that? So again, when you're trying to find a way to gather all that data, you really want to try to find one platform or one piece of software that's going to be able to connect to all of those. So no matter what you're facing, no matter what data acquisition challenge you might have, you're covered. So that's going to help you now. That's going to help you with your current machinery and your current devices, and it will help you in the future as well. So now you're bridging that gap of legacy machines and modern machines, and you're getting the data all together.
Yeah, because I mean, one thing that I've seen, and tell me if you're seeing this also, is manufacturers of equipment, want to upsell and offer more services on top of just, they want to sell the equipment, but then they want to sell you, a monthly or a yearly agreement, maybe for predictive maintenance or something like that. So, sign up for XYZ manufacturers cloud service, and they'll suck in data from their equipment, but then you're and it could be great. So being locked in isn't always a bad thing, because if you're getting, eventually you get locked into something, but you're only getting a partial view of it. And so, that's a frustration when I've been talking to some commercial clients, is that they like it, they're getting good results, but they're only connecting, I've seen it a lot with predictive maintenance where you're only getting part of the picture and you're not able to connect everything. Are you seeing that at all?
Yeah, of course. And I mean, so if we bring it back to even the 90s, like that was the whole point of, the foundation of the OPC Foundation was to attack that problem. And what you're really alluding to here is you want customers to be able to use, what we refer to as best of breed options. So I'll use, to not offend any automation vendors, I'll go outside the market, but let's say, if you buy an Apple product, all Apple products work super well with other Apple products. And they still work with other third parties, but you kind of miss out on that integration, that really slickness. But maybe Apple isn't the best at, I don't know, they're good at a lot of things, but I don't know, something else, right? But you want to use that particular thing. Well, that might not work with your core Apple product. So being able to go in and giving vendors the opportunity to use best of breed just helps everybody. And in my opinion, it promotes healthy competition.
Yeah. So we were talking a few weeks ago, Kyle, and you had a great example of a company that wanted to connect their CNC machine, and they were able to see results pretty quickly after instrumenting it. You want to share that?
Yeah, so it is, a similar situation where, as part of their manufacturing process, they had a big missing gap of when they went in to actually go and create some particular part that had to go through a CNC machine. And at that point, they were using, we'll call it sneaker net, right? So like going in, you've got someone writing down, doing quality inspection, just as a human looking at it. Hey, which is great, but what you're doing there is you're introducing human error. And sometimes it's not a big deal, but sometimes it can be catastrophic. So the example I always love to give is, if you're a baseball fan, you would know that the pitcher's mound to home plate is 60 feet 6 inches, which is such a weird specific sort of distance. Like, why isn't just 60 feet? And the story goes, apparently, I don't know if it's myth or not, but that when they were writing that out, that 0 looked like a 6. So like in that case, no harm, no foul. It's a fun little trivia fact. But in an automation environment or a manufacturing environment, that could be detrimental. Now, in this case, it's a little bit more, we're just looking at the quality and all that. Like it's not awful, but there could be risk there. Anyway, so by introducing Kepware, I think it was MT Connect we may have used, but the customer is able to go in, actually look at these values coming directly from the machine, and get quality data that was time-stamped, more accurate, and most importantly, more repeatable. So when we look at OEE, one of the ways to improve that is, improving quality. How do you improve quality? You want to make sure that a process is repeatable. So by getting that insight, they're able to go in and correct a few items, essentially, to go in to help that process run more repeatable, and therefore increase that quality. And again, they're only able to do that by seeing that data, transforming that data into actionable information, and then going out and actually implementing those changes.
Yeah, and I think what we're sort of hinting at is also this quality aspect is also solving that problem of, there's an employment gap and a lot of aging workers who might have, great skills. John and Jane have worked in this factory for 45 years. When they eventually retire, we're not trying to automate people out of a job. It's more, we're trying to digitalize John and Jane's knowledge of 45 years, because it's going to be very difficult for them to train the next employee, or it might be hard to even find another employee. Mm-hmm. So you're sort of digitalizing best practices, whereas the person writing the notes on a clipboard, that may have worked for a long time, but at scale it's going to break down.
It's all about enabling the workforce. That's really what it comes down to.
Because I think a lot of people are afraid, they hear automation, they think job loss, and that's not necessarily what we're talking about. Instead of improving quality, having people do more important high-level jobs rather than writing those numbers on a clipboard, they can be looking at how to actually improve the process. Mm-hmm. So if we're to pivot, we talked about device agnostic. You need to connect everything, no matter the maker, no matter the age of the machinery. What about destination agnostic? So obviously there's a lot of talk about cloud, but it's massive. Don't get me wrong, but a lot of factories and big industrial companies aren't ready to go to the cloud, aren't comfortable with it from a security or privacy standpoint, or it just doesn't make cost sense for them. It is expensive. They might have an on-premises database and warehouse and they're happy with it, but you need to be able to send your data wherever it needs to go. So you might have a Snowflake implementation, you could have an Amazon, and of course you could have one or several on-prem databases, and really that's one of the keys, is not just instrumenting but also connecting. So what are you seeing out in the field when where's the data going to, and why is that difficult in many cases to get the data where it needs to be?
Sure, yeah. So there's a lot going on there too, and the kind of unique but kind of cool thing about industrial data is that there's sort of I want to say three, but it's really kind of two ways to handle the data, right? So there's the, hey, we need access to this PLC or device data for control purposes, meaning, hey, we're sending this data back and forth between a SCADA system or an HMI system. And so that's important. There's a lot of nuance that comes around that. But then the other part of it is monitoring and analyzing, and I guess to a degree storing that data. And there's nuance that comes with that. And what we're seeing, thankfully, is that it's kind of at this point boiled down to sort of two types of protocols, whether you're on-prem or in the cloud. And that's usually OPC UA or MQTT. And there's varying flavors of that. So you could have Sparkplug B over MQTT. You could just have plain Jane JSON over MQTT. I won't go too much in the weeds there, but in general, those are kind of the two. And a question that we get a lot, which is really interesting, is like, well, which one is better? Which one's best for my factory? And the answer is kind of like, with most things automation, well, it depends. Like, what are you trying to do? However, rule of thumb is typically if you're sending something to the cloud, you're typically going over MQTT. And the reason for that is if you're sending data to the cloud, there's a very, very high probability that is just monitored data. So looking at, percentage yield, part counts, status, uptime, things like that, things that have nothing to do with control are being sent off for analysis. They're being sent off for, storage purposes. And then if you're looking more so typically on the factory, that's a little bit more OPC UA. Those are typically a little bit more control focused. So, hey, sending this bit to change the set point of my temperature, or increasing the torque of this particular VFD so it can control the motor a certain way. So it really, when we look at this, it kind of comes down to, well, do you have, what are you doing with that data? What type of data is it? How often do you need that data set? So what's really interesting now, or I guess backing up, going back to destination agnostic. So when you're looking for a solution, again, with the challenge of industrial data being sometimes it's control, sometimes it's just monitoring, you need the solution that is able to do both of those things. So again, you need something that's device agnostic. So I can connect to a bunch of different flavors and different types of devices, different protocols. But then that same platform also needs a way to transform and translate that industrial data into something like OPC UA or MQTT to get it to those destinations, whether that be in the cloud, on-prem, or sort of a mixture of both. So again, like when it comes down to, which one is better, it depends on what you're doing.
Yeah, one area I've seen companies struggle with is when they're moving industrial data to the cloud is you don't want to necessarily move all your data. I mean, you don't need, it's not helpful to have, instrumented, the HVAC. You don't need to know every second what the temperature is, even though it might be throwing off that data, or you might have a status, something that says this machine is working, it's on, it's on, it's on. You don't want that. You don't need it. It's expensive to store, and it has no usefulness. So how are you seeing companies sort of decide, what data do we want to move? Do we want to retain? Because there is always, we've sort of been told that data is the new oil, which I have some issues with because it's not all data is useful. I mean, oil is you have to refine it, you have to transport it, you have to get it into the hands of people and companies. Data is, similar, is it doesn't necessarily have value on its own, especially if it's not telling you anything useful or interesting. So how are companies sort of approaching this? I can't capture everything because I don't have an unlimited budget. So what choices are we going to make?
Yeah, I mean, ultimately, actually, a friend of mine in the industry said this even a few years ago, and it's still true today, where the technology has gotten to the point in our industry where it's, what do you want to do? Because we can probably do it, right? So to your point of like, hey, what data is good, what data is bad? Like, well, what are you trying to increase your productivity? Are you trying to, decrease your downtime? Are you trying to look for efficiencies in, even taking it outside of automation? Like, are you looking for efficiencies in your supply chain? What is it? What do you need to do with that data? And then kind of work from there, work from the goal, and then just work backwards and work with your OT engineers of what does this data look like, and what devices and machines should I be hooking up to, and also from the get the IT people involved, being how can we store this long term? How can we get it to the cloud securely? How can we get it to our own private servers securely? What does it look like for redundancy with some of these storage entities? What does that look like? So getting all teams involved is super important for that. But again, it always starts with, you got to know what the overall goal is, because to your point, there is so much data out there that it's almost overwhelming. Now, an interesting thing that, and again, this is kind of just like my observation, and it's not true everywhere, but there's been this really interesting shift. So when I joined this, or I started my career in this space, it was at a point where Ethernet was kind of finally making its way down to the plant floor, and all of a sudden people had access to data, and they asked the same question you did, which was like, "Oh, just I can do so much with this. Give me all the data." And our answer was always like, "Hey, sure, we can do that, but just know we're going to give you all the data, and it's more than you might think." And ultimately, what ends up happening is, "Oh, geez, you're right. This is so much. You just gave us 100,000 data points for one machine. We have 100 machines. That's so much. Hey, we only need 4 points of data from each of those. So just give me those." But now it's kind of taken a little bit of a shift where, through cloud technology, moving all the resources, moving all the storage offsite, having more resources to do bigger data analysis, it's almost shifted now where it's no, go ahead and give me all the data, because now we have tools to analyze big data, to analyze all that. It's not true everywhere, but there is a shift of, now just give me everything and let my AI model take care of it.
Yeah. Yeah, I think you brought up a great point in terms of you got to set out, because I mean, research is that 80 to 90% of AI and ML projects fail. And I think you hit the nail on the head. Is companies, want to do something with data, and so they hire a couple data scientists. I had a client who hired 3 data scientists. They had a year to do work. They came up with some interesting tidbits. They didn't operationalize anything. They spent months just deciding what algorithms to use, because there was no mandate. I mean, the business leaders hired this team because basically data is the future. We need AI, but they didn't define what the problem is. So these data scientists were just sort of having fun with the data and getting some small insights, but nothing really useful, because they were never told, we want to do X, we want to do Y, we want to reduce downtime. They had no mandate. And the other great thing you brought up is a hybrid team. You can't this isn't an IT problem, but it's also not just, you can't have just the business deal with it, because, and I also hate, there's IT and the business. I mean, they're all one. Every company is a technology company these days. I mean, if it's an agriculture company, if it's a retailer, they're all technology companies. So you can't have IT and the business as 2 separate entities. But also you need to form a hybrid team where you have business leaders, you have technology folks, you might even need legal or privacy involved in there, and also some subject matter experts who really know the process. So, when we're talking about a factory, you need someone who's on the floor of the factory who understands how it actually works, because you could have the business folks and the IT folks saying, well, this is a better process, and the guy who's actually on the factory floor will say, we can't change the process in that way. There's space requirements or OSHA requirements or what have you, and we can't just rip everything up. We are in the real world. So why don't we shift to this idea of creating one data hub? And I think that's sort of the ultimate goal, is you connect your you connect your devices, no matter the age, no matter the make. You move your data somewhere or to a few different places, so cloud, on-prem, couple different clouds, and then really you want to create this one data hub to launch new use cases. Probably your first use case is defined before you even start this process. But then once you have your data hub, well, then you're able to start figuring out, all right, so what's 1, 2, and 3 are use cases that we want to tackle, and what are some, when I'm consulting with companies, I always try and push to have a quick win. I mean, how is the data team going to convince the rest of the IT folks and the business folks that this actually is going to work and you're actually going to get benefits? Is what are some quick wins to say, all right, this is worthwhile. Now go off and do an 18-month project. We trust that you guys know what you're doing. So this idea of sort of a single data hub, I think is where we want to go to sort of revolutionize the business, future-proof the business, and come up with new use cases that you haven't even really thought about the possible yet. So, and then you mentioned earlier that paint example. I'd love if you your view on this one data hub, and then if you could share that example, it'd be great.
Yeah, let me start with that story, because I think it actually paints a pretty good picture about the importance of a
no pun intended.
Yeah. Darn. All right. Oh man. Yeah. Anyway, touche. Yeah. So this story was maybe 5 or 6 years ago, but we were working with an automotive customer, and we helped them connect to a bunch of different devices out on their plant floor, and everything was great. And what ended up happening was they noticed that year over year, every time in this, we'll call it the April-ish time frame, they got this really weird paint quality issue for a few days, and they couldn't figure out why. It wasn't super catastrophic. It wasn't like, oh my gosh, we lost $1 million, but it was enough where it was, yeah, this is kind of significant. Let's try to look into it. And for months and months, people were looking at this. They couldn't figure it out. And eventually what ended up happening was someone higher up with access to, we'll call it, different databases, not just automation, but other entities, was able to kind of put all this data together, looked at it holistically. And thankfully, using Kepware, they had connected to their HVAC system using our BACnet driver. So they were able to get the building environment, data from this. And what this person noticed was that during that time of the paint quality issue, they noticed that it was the shift in their HVAC system from going from the heat to the cool, because it was the springtime. And I forget the exact nuance, but essentially they determined like that shift going from the heat to the cold, there was like a lot of dust in I think that's what it was. Like there's a lot of dust in the systems and all that. And that in and of itself was causing the paint quality issue. So they're able to, look at it, adjust, and ultimately improve the quality, improve productivity, so on and so forth. Now, the cool thing about that story, right? The lesson learned is, hey, you really need that complete data set, because that is a very unique problem. And just looking at the machine data or even the human data of some of those manual processes, that wasn't it. It was something else entirely. So looking at, I guess, they didn't necessarily have AI back then, but if your AI, your analytics platforms, that's only going to be as good as the data that you feed it. So the more data you have, the more complete that data set, the more accurate those informed decisions are going to be. So tying that back to the data hub, the reason that's so important actually comes down to contextualization, essentially. Hey, you're aggregating a bunch of different data to one central location. And the advantage of that is now you have a single source of truth where any analytics that are coming outside the factory floor or wherever is from this one particular area. It's all here. The second part of it is, as we kind of described before, there's the challenge of going from legacy equipment in modern equipment, and then somehow trying to translate that into more modern protocols, OPC UA, MQTT, whatever it might be. But even doing that, there is so much more that is missing. And what I mean by that is, if we look at even a simple, Modbus address, we look at, address is 40,001 and I'm getting the value of 7. To a data scientist, like, well, what does that mean? Maybe to a controls guy or person, they can look at it and go, oh, I know, that's on this machine. That's this address. 7 is the part count. Hey, we're golden. But to a data scientist, someone way further up the stack, they're going to have no idea. However, if that industrial data is contextualized using, that information from the OT folks to give that contextualization, that makes the data scientist's job so much easier. And I think, and maybe you can flash it on the screen or do whatever, but it's something to the effect of, I may screw it up, but something like 80% of the time, a data scientist's time is used scrubbing data and cleaning that up. So having that data hub that's contextualized will help reduce that down. Again, I'm not saying like this is the end all, hey, you're gonna have 0%, but it's mitigating that percentage way down so that it's much faster. It's a much faster time to value once you have that data contextualized.
Yeah, and I think we're talking about, when we're talking about this industrial data, a lot of it, or almost all of it, is time series data, which very difficult. If you talk to data scientists, that's some of the most challenging data to deal with. And also when you're transporting it, it has to be accurately time stamped, and that's a big ETL for timestamp or time series data is more difficult than other data, and cleansing it, that's that of 80%. I think it's some research has brought it down a little bit, maybe it's 78%, but you're still wasting a lot of time of highly paid professionals just sort of working on the plumbing versus actually doing something with the data to get value from it.
Yeah, and honestly, and that's sort of where I see a lot in our industry where a lot of companies are going, and it's this new concept or this new space called industrial data ops that I could sit here and try to define it, but quite honestly, in my opinion, it's still defining itself. I think we're zeroing in on what that definition is, but it varies. But essentially, the idea is: can we collect data? Can we aggregate data? Can we contextualize it? Like those are sort of the 3 big things. And ultimately, what I think we're aiming for is: can we take and essentially model this data before it gets up for further analysis? So what I mean by that is, hey, if we look at a pump, I want to be able to go into my data hub, look at this pump object, and know the real-time data from it. So what is is it on or off? What is the current flow rate of this pump? What's the current pressure at? But hey, maybe I also want to see the running average of the flow rate for the last month. For some reason, I need to know that. Well, now I'm no longer pulling in real-time data. I'm pulling from a historical data. I'm pulling from a historian. But maybe also it's important to me to know, well, hey, I would love to see when the last time that this particular asset, this particular pump was serviced. So hey, can I pull in some other report, like a maintenance report that said hey, Kyle went out and he worked on this pump last week. Here's some of the notes from it. I would want all that together, so that way someone further up the stack who has an objective of, hey, I need to help improve this particular pump's flow rate, or I need to make this run more efficiently. I'm probably going to want all of that data, not just the real-time data. And in the past, you would have to go to each of those individual assets, go directly to the historian, maybe pull something from your data server for the real-time data, go to the maintenance work order place and pull that all together. That takes a lot of time, depending on how integrated those systems are. Maybe there's a lot of security stuff you got to go through, but it's a pain, right? It takes a lot of time. What we're saying and what we're aiming for is, can we just do all of that and model all of that before it goes up the stack to other entities?
Yeah, you really want to build repeatable data pipelines. And I mean, some of that is also it's not just systems you're entering, but it's also, having to interact with other humans, which is sometimes a big bottleneck because the engineer in charge of that pump, he's not motivated to get you that data. That's not his mandate. He's not compensated to do that. So it's sort of on the back burner for him, and you gotta, email him every other day begging for that data. And eventually maybe you'll get it, maybe you won't, maybe it's 6 months out of date. And so it's really sort of how do you open up the data to anyone who needs it. And oftentimes, we're not talking about super secretive. In many cases, this isn't data that needs massive protection over it. And so sometimes it's overly secure is what I find also.
Yeah, it can be. It depends. And again, at the end of the day, it's if you want to address a challenge down on your plant floor, or you're trying to increase your efficiencies, the way to do that is starting with information superiority. In order to get that, you need a truly complete data set.
All right. And I know you've been biting your tongue, Kyle, but why don't you spend the last couple minutes telling us about what Kepware or PTC Kepware is up to and where you guys are going.
Sure. Yeah. Be happy to. So a couple of things. So for those who don't know Kepware, you can maybe kind of put the pieces together here, but Kepware is a device and destination agnostic data acquisition platform. So what that means is we have the ability to go out and connect to a huge variety of different types of machines. We have over 150 what we call device drivers. So you can think of that as, hey, when you buy a new printer and you plug it in and it says, oh, connecting the HP printer. It's those, but on an industrial level. So have over 150 of those that support over 300 different types of protocols. We even have a few drivers that allow you to actually go in and script and create your own driver. So if you have, Dan's Raspberry Pi or something, like we can go in, maybe that's a bad example, but you can go in and kind of help pull some of that data. The other part of it is we are very destination agnostic. So, hey, if you're sending it, over something to like an HMI or SCADA system, hey, we got you for OPC UA. Hey, you're still running legacy stuff. Yeah, we support OPC DA. Hey, you're going to the cloud. We've got MQTT. You're going to like an ERP system or maybe your homegrown dashboard. Yeah, we can support REST. So we can do all of that. And the great part about Kepware is we have always been and will continue to be just agnostic. So, hey, we don't necessarily care where the data is going. We just want to make sure, like our job is to make sure it gets there successfully. Now, I'll put my PTC good corporate citizen hat on. Yeah, of course, we have a native integration to ThingWorks. That's great. We'd love for you to do that. But at Kepware, we also understand that's not always the case. So let us help you get there. And that's the same thing for the cloud providers. You're using Azure. Hey, that's awesome. They're a strategic partner of ours. Great. We can help you out. But same thing. Hey, if you're using AWS, sure, we can get you there too. So all of those things. The other advantage is, we are a standalone decoupled solution. And why that's important is, what we touched on earlier, where if you've got a big company, you're kind of locked into their ecosystem and they make it sometimes pretty difficult to go outside of that ecosystem. So we are decoupled from that. So, hey, if you decide that you don't like your SCADA system and you want to swap it out with someone else's, hey, great, you can do that because you had that connectivity layer already figured out with Kepware. So that's where we're at. We originally started as what we referred to as like a point solution. So, hey, you need this PLC to talk to this HMI system and they're different vendors. Sure, we can do that. That's how we got our start. But now, because of the shift in the market, because of the shift in the industry, because of the increased demand for data, that same concept and that same technology that we've had for 30 years is now being applied differently. So we can actually see ourselves more as an enterprise level connectivity platform. And with that comes things like remote configuration with our new Kepware Plus offering, meaning, hey, you log into an instance of SaaS somewhere, and we've got this single pane of glass. We can go out and we can configure our 200 instances of the Kepware server out there. And to be clear, that's just configuration. We're not sending your industrial data to our cloud. It's just that configuration. So really what we're looking at is how can we help address or how can we better address this need for a complete data set across our entire enterprise, not just this one particular machine.
All right, great. Just want to say thanks, Kyle, and thanks for everyone who's watching. This is RT Insights Research webinar, and we focused on IoT factory automation and keys to future-proofing your operations. Have a good rest of the day.